We've all been there, right? You're using an app, it crashes right when you need it most. Or you're on a website that just, well, it doesn't work. And you're left wondering how, with all this incredible technology, can't we just build perfect software to begin with? It turns out there's kind of this secret rule book that all software testing follows. And today, we're going to flip through it together.
And that really is the million-dollar question, isn't it? It's at the heart of every tech company, every project, and yeah, every user's frustration. We kind of think developers should be able to just write flawless code. But what if? What if the goal isn't flawlessness at all? What if chasing perfection is actually the wrong way to go?
Here's the thing. Building software isn't like building a bridge where you have one fixed blueprint. It's messy, it's complex, it's alive. And the best companies out there, they get this. They don't aim for zero mistakes. No way. They aim for a brilliant strategy to manage those mistakes. And that strategy is built on 7 kind of unwritten core principles. Okay, so first things first. Rule number 1 is the big one, the fundamental truth that changes how you see everything. Bugs are going to happen. They are totally inevitable. And they're not a sign that someone failed, they're just a sign that something is being created. This first principle is so important. Finding a bug proves, yep, there's a problem here. But, and this is the key, finding no bugs doesn't prove the software is perfect. Think of it like this. It's like you're fishing. Just because you didn't catch a fish today doesn't mean the lake is empty, right? It just means there weren't any fish right where you dropped your line. So once you accept that bugs are inevitable, you have to start thinking strategically. You have to think like a tester. And that brings us to the next foundational truth, which really gets at the mind-boggling scale of the whole challenge.
Which brings us to rule number 2. You can't test everything. It is impossible. You might be thinking, come on, why not just test every single option? And the answer is a wild little concept called combinatorial explosion.
So check this out. It seems so simple. You've got a username field and a password field. You want to test them. Maybe you try a valid name, an invalid one, a super long one, a short one, and maybe a blank one. That's 5 options. You do the same thing for the password field. 5 times 5? 25 combinations. That sounds totally doable, right? Easy.
But now, look what happens on a real-world app. Let's say an insurance form or a mortgage application. You might have 15 fields. If you only test 10 different kinds of inputs for each of those, the number of combinations just explodes. We're talking 1 quadrillion. That's a 1 with 15 zeros after it. To run all of those tests would literally take thousands of years. It's physically completely impossible.
So what do? This total impossibility leads us right to the core strategy of all modern software testing. Since you can't test everything, you have to prioritize. You don't just search for bugs randomly, you launch a targeted mission based entirely on risk.
This all leads to a really interesting question. Let's imagine for a second a team actually does it. They build a piece of software that is, for all intents and purposes, technically perfect. No bugs to be found. Does that automatically mean it's a huge success? Well, the answer might surprise you.
And this is rule number 3, what's known as the absence of errors fallacy. Think about it. A team builds the most solid, bug-free calculator app the world has ever seen. But what if everyone actually needed a photo-sharing app? Fixing every single tiny defect in a product that nobody wants or needs is, well, it's a pointless victory. Quality isn't just about the absence of bugs. It's about the presence of actual value for the user. Okay, so if we can't test everything and bug-free doesn't automatically equal success, then how in the world do we operate? Well, the next set of rules are the tactical plays. They show us how to test smarter, not harder. Pretty much every piece of software follows a journey like this, from just an idea all the way to a live product in the wild. And understanding this journey brings us to rule number 4, test early. The timing of your testing is absolutely everything. And the reason for that, in a word, is cost. And this chart says it all. A mistake found way back in the requirements phase, that's cheap to fix. A quick conversation, a change in a document, but that exact same mistake, if it's found after the product is live, it can cost thousands, even hundreds of thousands of times more to fix. Not just in money, but in damage to the brand and its reputation. So yeah, Testing early isn't just a good idea, it's an economic imperative.
All right, next up is rule number 5, defect clustering. You've probably heard of this as the Pareto principle, or the 80-20 rule, and it absolutely applies to software. It basically says that about 80% of your problems are going to come from just 20% of the code.
And I absolutely love this analogy. Bugs are social creatures. They don't spread out evenly. They cluster. They like to hang out together in the gnarliest, most complex parts of the code. So the job of a smart tester isn't to search the whole house from top to bottom. It's to listen for the music and find where the party is. Because once you find one bug in a feature, you can bet its friends are hiding nearby.
This leads us to our 6th rule. Testing is all about context. There is no one-size-fits-all recipe that works for everything. For a banking app, you are obsessed with security. You're trying to break in every way you can. For a mobile game, you're hunting down performance issues that cause lag. For an e-commerce site, you're making sure that checkout process is as smooth as silk. The testing has to match what the product is and where its biggest risks are.
And now for our final rule. This is maybe the most counterintuitive one, the one that's a real pro move to understand because it can trip up even the most experienced teams. It's rule number 7, the pesticide paradox.
This comparison is just perfect. If a farmer sprays the same exact pesticide on a field over and over, what happens? Well, the pests that happen to survive are the ones with some kind of natural resistance. They breed, and pretty soon that pesticide is useless against the new, stronger generation of pests. It is exactly the same with software testing. If you run the same set of tests over and over again, you'll get really good at catching the same old bugs. But your tests will become ineffective at finding new bugs. So to stay effective, you have to constantly review and refresh your tests, looking for new and creative ways to break things. So, we've walked through all 7 of these principles, from the fact that bugs are inevitable to the impossibility of testing everything, all the way to these paradoxes. What does it all add up to? What is the real goal of testing anyway?
This right here is the big takeaway. Good testing isn't really a bug hunt. It's a discipline of risk management. It's how we deal with the reality of inevitable bugs and impossibly complex systems. It's how we build confidence that the most important things work, and ultimately how we deliver something valuable to the people who are actually going to use it.
So here's the playbook these rules give us. It's simple, really. First, you just accept reality. Perfection is a myth. You're not going to find every bug. Second, with that knowledge, you get strategic. You test early, and you focus your firepower on the highest risk parts of the system. And finally, you stay on your toes, constantly adapting your strategy as the software itself changes and evolves.
And that brings us to you. Now that you know the unwritten rules, think about the apps you use every single day. If you were suddenly put in charge of testing your banking app, or your favorite social media feed, or that game you can't put down, where would you focus? What's the biggest risk? Thinking like a tester doesn't just explain why technology works the way it does. It gives you a completely new way of seeing the entire digital world.